for the data to be feasible for your problem, such as the permutations, right? Well, so, truth be told, permutations are probably the most studied in the literature. That's usually what people do research on. But you could imagine other types of mathematical structures also which require respectful. All right, so what we want to do today is another one, the last of the crossovers, really. When we do the mutation, I may suggest a spin-off, but that's just a variation of a heuristic mutation, which we'll do a little later. But the last one we want to do for today is the shorthand acronym is ERC, which stands for Edge Recombination Crossover. Now there is there are slight there's slight variations of the original method, and then there are many advanced variations in the subsequent research. This version was this concept was actually introduced, if I'm not mistaken, in the 1980s. So you're dealing with 35 to 40 years of research since. But I should make you aware there's one step where the Wikipedia, when they summarize and give you what do they call that, pseudocode. So in the case of, hold on a second, sorry. Yeah, so the Wikipedia, when they give you pseudocode for ERC, Edge Recombination Crossover, they do something, well, you'll see why it's so terrible, but they do something slightly different. For this and all other discussions, such as CX, OX, and PMX, you're responsible for the way we do it in class. And the same thing with CARP's problems. There are many variations out there, but you're responsible for the original definition, the way we do it in class. So please understand, on an exam, you have to follow the notes. I do understand there are many other variations out there, but I can't be responsible for all of them. And I'm giving you what is the classic original versions of them, and you understand many years of research since. All right, so ERC is very different than all the others in one major aspect. And its nature, while it lends itself to graph problems, it doesn't really have to have graph problems, but you'll see the heuristic that it wants to use does lend itself to graph problems more than other types of problems. But it doesn't have to be. Anyway, the concept is the following. A permutation so far has been thought of as individual numbers in sequence. So that's what most people think of it, and it's not terrible. It's been thought of independent numbers in sequence. The reason I say independent is that there is no local neighborhood. You don't look at the number before and the number afterwards and say, oh, they might be related to the number that in the middle. But the ERC uses that type of information. But the ERC tries to encapsulate some of that neighborhood information, encapsulate some of that local neighborhood information. That's the idea. And then people take this, well, why stop there? Maybe it's the neighborhood of the neighborhood, and you can imagine things get pretty wild after a number of years of research. Okay, so encapsulate some of the local neighborhood information. All right, so let's do this. Okay, so we need an example. Let's see, I worked out an example. I can do it randomly, but might as well for the save us time. All right, let's do it. I think in the original paper they have the following. Oops, sorry. In the original paper they have the following two permutations, which are chromosomes. And then let's copy. I just want to see. Yeah. Okay. Good. Let me copy and paste the data of the parents individually, because we're going to need to take a look at them individually in a second. All right. Here they are. All right. So. This is the, actually, you know what, let me do a text join. Text join. Okay, skip, ignore those, no, just so it won't affect us. Okay, and then, fine. All right, so P is just so that everything should fit on the screen. These are the parents, and P means parents. All right, so just I like a little, well, actually, no, I think I could do it. Parent one, I think it'll work. All right, here we go. Now, we have to first call which is to gather together all the information local in the neighborhood. All right, so we get a chart. So let's write down all the members of this neighborhood. Let me see what's about half. Yeah, that's fine. Okay, let's give it some room, and then G, H, I, J, K, and again, it skips L for any reason they want. Not relevant to us. And again, I assume because they think it may look like an I and they don't want to get confused, but whatever the reasons are. Okay, so these are the individual values that may appear. I'm putting it in two columns only so that it'll be easier to see them all in one shot. There's no algorithmic reason why it can't be one long column. Okay? All right, here's the idea. You want us to record who are the neighbors of these letters. So, for example, A, if you go to K6, A on the first parent, position 9 in this list, is next to an I and a K. So let's write down I and K. But we're going to see, okay, so that actually works. We're going to be doing this in the listing it alphabetically, so I is before K. Good. But that's only the first parent. Now we look at the second parent, which is G and K. So now it's G-I-K-K, but in order to not have this redundancy, and more importantly, so let's say another little related heuristic, which is that the fact is that K is in the neighborhood of A in both parents. So heuristically, that seems to indicate that the genetic pressure, as it's called, the genetic pressure is trying to push, evolutionary pressure is trying to push the K into the neighborhood of A. So to make that stand out, and the notation is terrible, but this is the notation. To stand out, they put a minus. Where in the world they put a minus? I don't know. I'm not going to even guess. They actually do. In the original paper, it's a minus. Just understand that. So minus means it appears in both parents, but it's supposed to stick out, and the minus, I dare say it does. Okay? So we're going to put that down here. Let's write an heuristic, another heuristic. Is that if a data point appears in the neighborhood of a given value, data value, in both parents, then heuristically, ERC assumes, it doesn't have to be right, it's just that's in the heuristic they use, and ERC assumes that the, what's called the genetic pressure, also, oops, what is that doing? Oh, let's do that. Oh, no. Yes, good. Okay, good. It's easier to correct this. Good. Okay, that the genetic pressure, also known as the evolutionary pressure, more you see evolutionary pressure, some people call it. It's more the genetic pressure. I think what is trying to place K in the neighborhood of A, for example. Okay, here I'm giving an example. Okay, all right. So that's just a heuristic. You don't need the heuristic, the explanation to understand the algorithm, but that is the idea. Okay, we'll get back to the ranch. As I said, now we're up to B. So B in the first parent is next to a J and an H. Again, we look alphabetically, and the second parent, the B, is between an H and G. So the G is going to go first, and then the H gets a minus because it appears in both parents. All right, there's no had to be bolded, but that's okay. Somehow I don't know their format, how Excel does its default format. Okay, C. Now, C is an interesting one on both ends because it turns out to be the endpoint. But since we're generally talking about cycles and permutations, so we're going to have to assume that the neighborhood is both the one before and after wrapped around. So for the first parent, it's E and G, because E from 12 is C, E is 11, and then 1 is G. So wrap it around. And similarly, for the second parent, it's E and D. D from position 12 wrapped around, and E afterwards. So the E has 2. right? Because it's 11 in the first parent and it's 2 in the second parent. Okay, now we're up to whom? We're up to the D. So the D has a G and an M in the first parent, and then it has an A and a B in the second parent, so we're going to put it alphabetically, all different. Good. E. E has a C and a K. I'm sorry. E has a C and a K from the first parent and a C and a K from the second parent. Interesting. So now we have a double-double. Oops, yeah, Excel doesn't like so many minuses. Let me take care of it with this little quote, which makes it a comment. All right, F, I and J in the first parent. F has a J and an M in the second parent. That's at the minus J and then an M. Okay, now move across to G. G has a wraparound. Has a C and a D in the first parent, and G has A and a B in the second parent without a wraparound. In the first parent, it's in the corner, so it's a wraparound. 1 goes to 12 as well as to 2. H has a B and an M in the first parent. Again, why that bolded, I have no clue. B and M in the first parent, and H and a G in the second parent, which is alphabetically a GH. I has an A and an F in the first parent, and a H and a J in the second parent. All right, J. J has a B and an F in the first parent, and J has an I and an F, so that's going to be a minus F or doubles, and then an I in the second parent. Good. K. K has an A and E in the first parent, and an A and E in the second parent, so that's a little extra piece here. Oops, again, the minus is because of Excel. All right, the comment was because of Excel. M. There's a D and an H in the D and an H in the first parent, and a D and an F in the second parent. All right, so that is all the neighborhood information. Oh, there we go again. Minus. That is all the neighborhood information. Okay, sorry, sure who asked the H. Let me double check the H. Okay, H has a B and an M from the top, 3 to 5, and H has a B and an I. Oh, misprint. Thank you. Yeah, of course. Yeah, it can't be self-referencing. Good, thank you, Shuguan. Good catch. Right, H can't reference itself. Otherwise, you don't have, if H center and also in the neighborhood, then that will not be a permutation. That would be a commission error. Yeah. Also check D. Okay, thank you. All right, so Wei says D. Let me check. M and G in the first parent, and M and C. Oh gosh, wow, I've been sloppy. All right, let me do that again. Yes, correct. The wraparound in the second parent, 11, 12. 12 is the center, and then 1 is C. Now let me double check the D. So that's an M and a G. Oh. Wait a second. Let me. D has an M and a C. Oh, so it's a minus. Wow. Good catch. I don't know why I made that error. Okay. Yeah. No A? Where am I getting this A from? I'm not. It doesn't exist. Okay, hold on. M and G, correct. Yes, thank you. Yeah, I don't know why. All right, I guess not enough breakfast. Wait a second, I know I did it wrong. Hold on. Let me clean it up. CG minus M. Is that correct? Let's see what you got. Yes, thank you. Thank you, Anna, and thank you, Austin, and thank you, Wei. Correct, good. Any others? Or it seems okay. Good. Haste makes waste. Okay. Good. Okay, I'm sorry. Now, here's an important point that you should realize, although some authors, unfortunately, make a slight mistake. All right. Based on another heuristic that you're going to have, and this is another heuristic, which I won't mention, which we will get to later. We should bump into it. Based on another heuristic, so there are a lot of heuristics here. Based on another heuristic, it should come out. I'll say what that heuristic is later. It should follow that ERC is a monoploid one-child approach. Crossover, okay. and not haploid. Now, for purposes of an example, I'm going to relax that condition so that we can have a second. You know, some books sort of say a second, but it's actually not true. So please be careful on the notes. I want to do two examples just so you should get used to it. But understand that second example, according to this, can't actually be, because I'm going to say, if not the first child, then what is the second child? But understand that can't actually exist because of a heuristic that you'll be forced to using. All right, so ignore that for now. All right, so we'll talk about that later. Okay, now let's get started. So the idea is that the heuristic another heuristic is another heuristic, which I think maybe, if not complete, maybe the heuristic I'm referring to in 16, we'll bump into it later. Another heuristic, I believe this is it. Another heuristic is that if there's a tie in any situation, then the alphabetically first available option is chosen. Okay, so we'll see a few examples of that, including right now. Now, the goal here is you want to, in theory, okay, another heuristic. Another heuristic. If there's a choice, more minuses the better, because that means that the above heuristic, the first heuristic holds true. That follows from the first heuristic. Okay, first heuristic. Right, okay, for example, this is marked by a minus in front of the repetitive data point, repetitive negative. Good. All right, first heuristic, second heuristic, third heuristic. Let's do it that way. So the truth is, I think this is going to be based on the third heuristic. Based on the second, maybe second and third. Certainly based on second. I may have to change this to second and third. But based on the second heuristic, it will follow that it's, we'll see why. It'll follow it's a 1 point crossover and not haploid. No, it's second and third. Sorry. Yeah, it is second and third. See it right now. All right. The point is we don't want to have ties. Well, okay. So this is the difference. Okay, so let me explain that. The heuristics have been provided. The heuristics have been provided so that the decisions are deterministic, decisions are deterministic, and not, which is interesting because usually you think of random, and not randomly chosen if there is a tie, or if the algorithm cannot. Sorry, if the algorithm cannot conclude on which data point to choose, data value point to choose. Okay, so the point is, the way I presented it, which I believe is the original paper, they didn't want choice. They wanted the heuristics to win over choice. Okay, now so I should note, that was the point I wanted to note. Note the Wikipedia implementation of ERC, meaning their pseudocode, argues with this. Argues and resolves ties randomly. Okay, so that's the difference I mentioned to you before. And resolves ties randomly. All right, you can see the argument either way, but that's the bottom line. The original version, which we're going to use in now and in and in the exams, are going to be this way. Okay, where the heuristics determine who to choose if you don't know who to choose, not random. All right, so now let's get started. So at this point, I see. So we have to count now. Well, I used to do it have a whole Excel thing to do it for me. But we need to count how many minuses there are. So there's one here, one here, one here, one here, two here, one here. Okay, so this is data values, data points. Okay. Oops, sorry. Data points. This is the neighbors. This is the number of minuses, which means how many times the neighbor repetitively appears, and then we do it all over again. The next part. Okay, flip this over so you can see it a little bit better. Okay, good. All right, and here we have 0, 0, 0, 1, 2, 1. Okay, excellent. The point is that the twos, so you want to pick the ones that have the most minuses, right? The more minuses, the better. The third heuristic says the more minuses, the better. So that would be here, number 2, as well as here, number 2. Right? But which one? Now we have a tie. E has minus C minus K. Let me verify that. Yes, good. And K, let's see, K. AE, yes, good. Okay, so both E and K data points have C, well, SCK. K has AE, but both of them have 2 minuses. That's a tie. But if it's a tie, what do? So heuristic number 2 says alphabetically choose. So who comes first? So the E will come before the K. Correct? The E will come before the K. All right, so let's get started. So therefore, E is going to be our first chosen, letter. All right, now we're going to look at the neighborhood of E. Okay, let me leave this up here. So now who's the neighbor of E? Okay, so E's already been chosen. So, well, I was going to put a letter through it. Oh, interesting. Maybe we'll do it that way. Insert to the right. Okay. So we already chose E. And now, give me 1 second. Let's put that over here. Right, we already chose E, so we're never going to choose E again. That's a commission error because we're dealing with permutations. So now, who is E next to? So let's look at the neighborhood of E, and we follow the yellow brick road. So E is connected to C and K, right? Now, I did you the favor to get alphabetically, even if and this is an error students always, well, not always, but a bunch of students always make. Okay, whatever. Every semester I get some student who forgets this point, more of nervousness. I think if they thought about it carefully, they'll realize the issue. But even if by accident I wrote K and C, right? Because in the first parent, look at the last 3 on the first parent, K, E, C. So you may have by accident wrote K, C, and then minus K, minus C. So then you may have by accident K first. But that would violate the second heuristic, which is alphabetically, that if there's a tie and C and K both have the same minus status, so then they alphabetically, you choose the first one, which is the C. So even if E were written as minus K minus C, as the neighbors, you still would choose the C. I took away that factor by automatically writing it alphabetically. So after the E comes the C. All right, now that we have the C, make it this way and this way, so it'll look a little nicer. And let me bold this. Yes. Okay, so now we have the E and the C. So what happens now? After the E and the C, let me see if there's a comment. Yes. Okay, Sheng. Professor, why is G included in the H neighbor? Oh, did I make a mistake? All right, G and H's neighbors. Let's look at H. B and M on the first one, and B and I in the second one. H, B and M, and B and I. B and M and B and I. Oh, they're 2 B's. Thank you, Cheng. There's no reason. I think it's because right here, if you look at it, the under B is a G, and right next. No, what? Wait a second. Oh, you're saying H. That must have been it. I was looking at the B, not the H. H. One more time. H is between M and B above, and H is between B and I below. So B minus B, I M. Thank you for catching that. Good. I'll change that again. Thank you for catching that, Jen. I appreciate that. All right, now we did a C. Oh, another comment. Okay, good. Yeah, great, thanks. So EC. After the C, let's get the C. So the D is first, but the E has a higher status. However, E, well, I would call it a heuristic, but I don't want to write it down because it's obvious. then in a permutation you can't repeat the value. So although in C minus is in E's favor, E is already there. So D and G, but D is first in alphabetically. So the next person is D. All right. So D is now chosen. All right. The D has a minus M. So although C and G is first, the minus status wins. Right. Third heuristic. The more minuses, the better. So the third heuristic would say that after the D comes an M, because that has the minus. All right, good. So let's write an M over here. I'm putting. Oh, you know what? Interesting. Yeah, I think we can move it over like this. Good. Yes, that's better. And then bold this and put this here. Okay, because it'll be easier to put the X's here. All right, so now we have the M. Okay, so the D has been chosen. The minus is in front of the D by the M. Oh my gosh, that's an error. Did it again. Wow, what a day, what a day, what a day. Okay, the M has an H and D above and has an F and D below. So it's F minus D. F. Wait, what? Say it again. Stop. D and H above and F and D below. So it's minus D, F, H. Yeah. Okay. Maybe one of you said it already. I don't know. Wow. Okay. Any more mistakes? Wonderful. Oh, this is a 1. Not that we really need it so much, but okay. Let me double check. M has H and D above and has a F and D below. Yes. Okay, good. Whew. Okay, so M, the D has already been chosen. So now we go between F and H, and F comes first. So the next letter will be an F. All right. F. Now, J has the status of a minus, so J will be chosen next. All right. Okay, so J is chosen next. Let's put an X in front of the J. Okay, F has been chosen. Now F is a minus next to the J. In other words, the J is B minus F I. F has a minus. So but we already did it. We already have it. Look at the child in row 24. The F's there already. So we have between the B and the I, so the B wins. Because the B is first, and that's heuristic 2. Second heuristic. All right, so the J, we pick the B. Good. All right, now we go to the B. And let's see. The H is a minus. Okay, that one's hands down. Okay, so now we go to the H. All right, the B minus B, but the B has already been taken. The I beats the M, besides the M has already been taken. So now we have an I. All right. Is this the one? Let me see. Well, we'll find out in 2 seconds. I. No, it's not the one. All right. A, F, H, and J are all equal letters, so the A is chosen next. All right. A is chosen next. Okay. Now, oh, this is interesting. I thought let me see. Wow. Okay, I thought the example would show already. The G, no, K. K is, K is next because that has the minus. Oops, not good. Okay. Oh, here it is. Oh, okay. Now, so this is the case, although it's a trivial, this now is the case why you have to resolve things, although admittedly there's not much left. At this point, the K has a minus A and minus E, both of which are equal, but worse, they both appear. Now, it turns out that there's only one G left, but imagine there were others. What would you do? So that's where Wikipedia differentiates between our second heuristic. Our second heuristic says that you have to pick the alphabetic first. So imagine there was an N as a value, and later that was not chosen, so and assuming that the neighbors were both zeros, no minuses, so G would be chosen first. In this case, it's trivial because G is the only left, right? But the point is, again, looking at the K, the minus A minus E, great, but A and E already exist in the child. Anyways, the bottom line is that technically based on the heuristic, also based on the fact there's no other choice, G will be the last letter. All right, so this is the child. Chu asked the following. First, can you explain how you got the child list? Row 24, Shu? That's what I was doing the last 10 minutes. Well, I'll tell you what, I'm going to do a second example, so follow along with that one. But all my talking now was exactly to create that child. Well, we're going to do a second example, so you can see it in a second. All right? All right, now, so that is the child that the